Hello, everybody. This is Brian from the Delta College Planetarium here to bring you the next episode in our series about the constellations. Last time we used the Big Dipper to find the Lion of Spring, Leo. This time we're going to turn our attention to the handle of the Big Dipper. In the spring, the Big Dipper is high in the sky after sunset. For the past couple of episodes, I've used the stars in the cup of the Big Dipper to find other constellations. Let us now look at the stars in the handle. Imagine that bend defines the arc of a circle, and continue that arc out away from the cup. It will lead you to this very bright orange star. This star has a very easy to remember name. It is Arcturus. We follow the arc of the handle to Arcturus. Arcturus is one of the brightest stars in the sky, and it is the brightest star in the constellation Boötes, the herdsman. Boötes is supposed to represent a person, but it's kind of an odd shape for a person. Many people say it looks more like a kite or an ice cream sundae. The body of the herdsman extends into a diamond shape above Arcturus, and two short legs extend in the opposite directions below. You will also frequently see Boötes drawn with an arm extending towards the Big Dipper. Boötes is located almost directly above the plane of the Milky Way galaxy, so there are few nebulae and star clusters in this region of the sky. Let's turn our attention to the stars that make up Boötes. In particular, let's take an in-depth look at that bright star Arcturus. Arcturus is the fifth brightest star we can see from the Earth. To the eye, Arcturus looks to be an orange-red color. Because of its color and brightness, I know that when I see Arcturus near the horizon, I can confuse it with an airplane, especially if it's twinkling a lot. But why is it so bright? Well, it's actually kind of hard to say. Imagine two lanterns in the distance. One is brighter than the other. What could be the reasons for that? Maybe one is just brighter than the other. Maybe it just throws off more light. Or maybe one is further away. Lanterns that are further away appear dimmer than lanterns that are close. Maybe it's a combination of the two. How can we figure it out? The only nearby star we can observe is the sun, and there's no way to tell if stars need to all be the same brightness. Maybe some are just brighter than others. Could we figure out how far away Arcturus is? If we could, and we can measure how bright it looks from this distance, we'd be able to figure out how bright it would look if it were at the same distance away as the sun is, and then we could figure out which one is brighter. So how do we figure out the distance? Cover up one eye and hold your hand out in front of you. Line your thumb up with some object in sight. Now reverse which eye is open. Your thumb will appear to have changed position versus the object you lined it up with. This effect will be more pronounced for objects that are closer than for objects that are further away. This effect is called parallax. You might not have ever thought about it, but your brain uses parallax all the time to figure out how far away things are from you. How do we apply this to the stars? You might have heard that our planet orbits the sun. The Earth orbits about 100 million miles away from the sun, and it takes 1 year to go through one orbit. 6 months from now, the Earth will be on the opposite side of the sun, 200 million miles from where we are right now. That baseline, the distance between those 2 points in space, is like the distance between your eyes. We should see Arcturus move as we orbit the sun, just like you see your thumb move when you switch eyes. Arcturus does move, but only a tiny amount. You're probably familiar with the idea that there are 360 degrees in a circle. When we need to talk about smaller angles, we can divide a degree even finer. There are 60 arc minutes in 1 degree, and 60 arc seconds in 1 arc minute. Over the course of 6 months, Arcturus moves 8/100ths of 1 arc second. In comparison, the full moon is about 30 arc minutes in the sky. When we use this tiny angle and compare it to the 200 million mile baseline around the sun, we find that Arcturus is about 216 trillion miles away, or about 37 light years. Comparing how much light we measure from Arcturus here, 216 trillion miles away, to how much we would see if it was just 100 million miles away, we learn that Arcturus emits about 170 times as much light as the sun. From 37 light years, the sun would just barely be visible to the human eye. Arcturus is far brighter than the sun. So if it's clear where you are tonight, go out and follow the arc of the handle of the Big Dipper to the bright star Arcturus and the constellation Boötes, and consider just how bright all those distant stars really must be. That's it for today. Next time we'll find another spring constellation and take a closer look at the color of all those stars. This is Brian from the Delta College Planetarium wishing you clear skies.